So in this question here, we are given a trolley of 1.5 kilograms that is stationary at point A at the top of a frictionless track. So when the trolley of 1.5 kilograms is released, it moves down the track. It passes point P at the bottom of the incline and collides with a stationary trolley of 2 kilograms at point B. Refer to the diagram below. Ignore air resistance and rotational effects. So as we said here, we are having this trolley at point A that is stationary at first, and then it is released to point P, and then it collides with this trolley at this point B. Now 4.1 says that use the principle of conservation of mechanical energy to calculate the speed of the trolley of 1.5 kilograms at point P. So what we're going to do is we're going to use these points here, point A and point P, to find the speed that the truck is moving, or the trolley rather is moving at this point. So we want to identify the speed V final here, whereas the V initial is equals to 0. So the V final we don't know, using the mechanical energy equation. So 4.1, so the mechanical energy says that it's mechanical energy initial is equals to mechanical energy initial is equals to mechanical energy final, where it's going to be equals to the kinetic energy plus the potential energy, all initial, equals to the kinetic energy final plus the kinetic energy, plus the potential energy final. So what is the initial kinetic energy? It's 1 over 2 mv squared initial plus mgh initial equals to 1 over 2 mv squared final plus mgh final. So if we take a look at this trolley here, at this very point, at the highest point, it is said to be stationary. So there's no movement of this trolley. So meaning that this is going to be 0. The kinetic energy initial is going to be 0. Then looking at this point here, this trolley is at the surface, so there is no height whatsoever. So meaning that this potential energy is going to be 0. So you're going to have mgh initial is equals to 1 over 2 mv squared final, whereas the mass of the trolley is given as 1.5 kilograms multiplied by 9.8, and the height, the initial height of the trolley is given as 2 meters. So it's going to be 2 meters equals to 1 over 2 multiplied by the mass of the trolley, which is 1.5, and the V final that we're looking for. So you're going to have, so we're going to cross multiply here. So it's going to be 1.5 multiplied by 9.8 multiplied by 2 and multiplied by 2, which is this one here. It's going to multiply this one, equals to 1.5 V final squared divided by 1.5 divided by 1.5. So V final squared is equals to 1.5 multiplied by 9.8 multiplied by 2 multiplied by 2 divided by 1.5. But because it's V final, so we're gonna V final squared, so we're just gonna put the square root, and then the V final of the trolley is gonna be 6.261 meters per second if you punch your calculator correctly here. Now the second part of the question says that when the two trolleys collide, they stick together and continue to move in constant velocity. So 4.2 says that the principle of conservation of linear momentum is given by incomplete statement below. In an the linear momentum is conserved. So here, you're just going to put in an isolated system, the total linear momentum is conserved. 4.3 says that you must calculate the speed of the combined trolleys immediately after collision. So we need to remember that we have the initial speed of this trolley here at this point P, which we just calculated, being 6.261 meters per second. So now collision happens here. So meaning that you have your trolleys, they've collided with each other here. So this is the 1.5 kilograms and the 1.5, oh sorry, and the 2. So this one is a 2 kilogram trolley. So there's a point of collision here. So we want to identify the combined velocity of these trolleys here, the V final, the combined. So what we're going to do is we're going to say let's first find the information for the 1.5 kilogram trolley. So we know that its initial velocity is equal to 6.261 meters per second at point P, right? And its final velocity is what we're looking for. And for the 2 kilogram trolley, its initial velocity is 0 meters per second because it was stationary, and then its V final is what we're looking for. So we're going to use the mv initial of the 1.5 kilogram trolley plus the mv initial for the 2 kg trolley, and then the mass of the 1.5 kg trolley plus the mass of the 2 kg trolley, they combine together and we'll have a final velocity. So we're going to substitute the information that we highlighted here. So the mass is the 1.5 kilogram trolley. Its initial velocity, as I said, is 6.261 plus the 2 kg trolley, which has a 0 meters per second velocity, which means this is going to be 0 equals to the mass, which is 1.5 plus the 2 kg and V final. So we're going to find the product of these two here, which will give us 9.3915 equals to, so you're going to add these two, it's going to give us 3.5 V final. Divide by 3.5 both sides. So the V final, which is the combined velocity of the two objects, is going to be 2.68 meters per second. 4.4 says that we must calculate the distance traveled by the combined trolleys in 3 seconds after the collision. So what happened is these trolleys collided. They collided together at these points. So this is a 1.5 kilogram trolley and this is a 2 kg trolley. So as they first collided, they moved to that direction. Let's say this is the point where they stopped. This is the point where they stopped. So it's 1.5 kg. This is a 2 kg trolley. So the initial velocity of the combined trolleys is 2.68 meters per second. So this is the initial velocity that we calculated when we wanted to find the speed of the combined trolleys immediately after collision. So the V final is equals to 0 meters per second. So this is the point where these trolleys are going to rest. So what we want to find is we want to identify the the distance traveled, which is the displacement of these trolleys at t is equals to 3 seconds. So what we're going to do is we want to find, so it's going to be changing v is equals to changing displacement over changing time. Because one displacement, we're going to cross multiply, so changing displacement is equals to changing velocity multiplied by changing time, which the displacement change in x is equals to, so the v final minus the v initial multiplied by your change in t, which the v final is 0 minus the 2.68 meters per second multiplied by your 3 seconds. So the displacement that you're gonna find is 8.04 meters. So it's gonna be negative 8.04 meters. You can just write it as 8.04 meters.
Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comment section below. Don't forget to subscribe to the channel for more videos.